Okay, here we go. So yesterday, guys, we learned the first derivative test. Maybe we didn't call it that, but so what did we learn yesterday? We learned that if f prime is positive, f is increasing, and if f prime is negative, f is decreasing. Right? So that's what, and then we can tell maximums whenever f prime changes from what to what? And minimums when f has a minimum when f prime changes from? Yeah. So that's what it is. So it says, for each of the following functions, use the first derivative test. That's what we learned yesterday. To find the local extrema. That just means find local or relative max and min. Identify any absolute extreme, if there is any. So here we go. First, take a derivative. So 3x squared minus 12x. I don't think anyone's going to have issues with that. Next, I'm going to find... Oh, my bad. Next, I was testing you guys. Next, I'm going to equal this to 0 to find critical points. So now you're just doing algebra here. So I'm going to factor out a 3, and I'm going to have x squared minus 4 equals 0. The only way this will equal 0 is if x equals plus or minus 2. Is everyone okay with that? All right, now I'm going to do a railroad track. I don't think that's the right thing to call it, but that's what I've been calling it. Well, in here, I guess. I think it's called like testing your critical points with using a number line or something like that. All right, so here we go. All I'm doing is plugging in values. A value to the left of -2, a value to the right of -2, and then a value to the right of 2 into my derivative. So if I put in like -10, so -10 squared is 100. 100 minus 4 is 96. All you care about is positive or negative. Positive times a positive is a positive. I'm going to plug in a number between -2 and 2. So like 0 or 1. Yeah. I think 0 is easier, but if you want to use 1, that's fine. So 0 squared is 0. 0 minus 4 is negative. Negative times a positive is a negative. And a number bigger than 2, like 3 or 10. 10 squared, 100 minus 4, again, 96, so positive. Are we okay? Yeah. What's up? Yes. If you plug in a 3, 3 squared is 9, 9 minus 4 is positive. Positive times a positive is positive. Okay. All right, so now that I did that, I know that I'm increasing, I know that f is increasing. Try to avoid using the word is or the graph. Be specific. So right in there somewhere, be specific. Be specific, be specific. I think that's from some type of nursery rhyme or something. No?
I was thinking like, don't be suspicious.
Oh, yeah, that's where he got it. All right, so here we go. Well, and you see how TikTok has influenced us? So, all right. I haven't had TikTok for like a year now, and see, it still came in there. Yeah, I've deleted it a long time ago. All right, let's focus, guys. Let's focus. So here we go. At -2, f prime is changing from positive to negative. So that means f has a what? Yeah, perfect. So I'm going to write f has a relative max at x equals -2 since f prime is changing from positive to negative at x equals -2. I just wanted to write that down. There's another one. Well, it's not a max, but at 2, f prime is changing from negative to positive. So think about it. If you're going from negative to positive, that means that f is going down and then up. So that has to be a what? Perfect. So I'm going to write that one up here. I'm going to write f has a relative min at x equals 2 since f prime changes from negative to positive at x equals 2. And I know it sounds like you're being redundant, but that's fine. How do we feel? Okay, perfect. We're not going to write long statements anymore. Well, maybe we will. We'll see. The next one, I'm just going to write what it is. Here we go. I have an expression here. Okay, what happened? That's it. We're done. Oh, there's okay. Yeah, that's answer the. Are there any absolute? Now think about it. Think about look. Okay, in your head, you're like I'm increasing, then I decrease for a little bit, and then I increase. So I'm not saying this is how it looks. I'm just gonna draw a rough sketch. It looks something like this. I'm going up forever, or I'm going up until -2, then I go down a little bit, and then I go up forever like that. Does that look like it has any absolute mins or max? No. Do you see how we did it?
How'd you know that?
From this.
Okay, but how'd you know it wasn't like the sinusoid?
Because I don't have plus minus, meaning that I would have gone. These are my only two critical points.
Oh, okay.
Okay.
Are we gonna do an example?
Yes, eventually we're going to do specifics. We haven't even talked about concavity. We're about to. What's up? Oh, I would have gone from positive to negative and that's it. Or negative to positive and that's it. Something like that. See, that has an absolute max. Or something like this. That has an absolute min. But if I go from increasing to decreasing to back to increasing, you have no absolutes. Unless you restrict the domain. That makes sense? Okay. So check it out. This one here, I got to take a derivative. So I'm going to write G prime. I got to do what rule? Product. First times derivative of the second plus the second derivative of the first. I'm tempted, guys, but I don't know yet. This is kind of changing the subject a little bit. I think I want to get standing desks. If I have an opportunity to get standing desks,
I would love that.
would you guys be
Yes.
cool with that?
Yes.
Or do you guys want somewhere to sit?
No, I personally am very lazy.
Wait,
so
Uh,
can you do everyone half and half?
Yeah.
Can you do half?
Maybe like put a standing desk in the back or something. All right, we'll see.
Love
I would,
I'm gonna try.
If not a few, I would like
I would
that.
use that.
All right, getting back to this problem, guys. Sorry. All right, here we go. I'm gonna factor out an e to the x. G prime of x equals e to the x, and I'm gonna have x squared minus 3 plus 2x. I'm gonna rewrite this. Actually, I'm not gonna put an arrow. I'm gonna put an equal sign. E to the x parenthesis x squared plus 2x minus 3. There should be red flags coming out of your brain. It's factorable. It's factorable. Two numbers that multiply to give you -3 that add up to 2. You guys gave me a look like it's not factorable. X plus 3x minus 1. Are we still okay, guys? So here are my critical numbers. I have a critical number at -3, and I have a critical number at 1. Why? Because -3 plus 3 is 0. 0 times anything is 0. 1 minus 1 is 0. 0 times anything is 0. Do I have any critical numbers? Do I got to worry about e to the x? No, e to the x is always positive. That's background knowledge that we should know from our algebra days.
Yeah, because
It's always above the x-axis. It has a horizontal asymptote, yeah.
What? Sorry.
E to the x looks like this.
it's
It's always above the x-axis.
What if there's a negative in front of
Then it'd be below the x-axis.
it? Okay.
but then it wouldn't ever go up.
Okay.
But it'll never hit
It will never hit 0. It does have a limit of 0, but it'll never hit 0. All right, going back, let's solve this real quick, guys. I do my railroad track. Here's my railroad track. I'm going to call it f prime. And I'm going to put these numbers, -3 somewhere and 1 somewhere. You don't have to worry about e to the x because e to the x is always positive. I'm going to choose a number like -5 and I'm going to plug it in. -5 plus 3 is a negative. -5 minus 1 is another negative. Negative times a negative, put a plus.
Wait.
Yes.
So if we just said that there's negative in the x, then it'd be below the x-axis.
E to the x is always above the x-axis.
But it's never gonna hit 0.
But even the -5.
Is always above the x-axis. E to the -5 just means 1 over e to the 5th, which is just some number that's positive.
Yeah.
Okay. Well, we're good, miss. We're good. All right. Are we still okay, guys? All right. I'm going to choose a number between negative 3 and 1, like 0. If I choose 0, I'm not worried about e to the x. We already established that's always positive. 0 plus 3 is positive. 0 minus 1 is negative. Positive times a negative is a negative. Do you see how we're doing it? I'm going to pick a number bigger than 1, like 5. You don't care about the e to the x because we already know that's always positive. 5 plus 3 is positive. 5 minus 1 is positive. Positive times a positive? Positive. So now I got to say what's a max, what's a min. At x equals negative 3, is that a max or a min? It's a max. So I'm going to write x equals negative 3 is max on f. Make sure you're specific on f. What about 1? X equals 1 is min on f. Why? Because of the reasons up above. F prime changes from positive to negative. F prime changes from negative to positive. I just wanted to fit it all in here. How do we feel, guys? Okay. Do we have what?
Do we have an absolute?
No, we don't have an absolute. Because we have the same thing that's going on over here. Positive minus positive. So next time I'll just delete the absolute extrema question.
Is that every time it's a function I can function?
Yeah. Well, yeah, we need more experience. So don't worry, we'll get to some more experience. All right, ready, guys? All right, what does it mean to be concave up, concave down? What is an inflection point? Let's do a quick review. It's not going to take long. It's literally going to take 10 seconds. Draw that. This is concave down. This right here is concave up. In between concave down and concave up, looks like right there, that is called an inflection point. So using your inference skills, an inflection point is where concavity changes. Are we okay? All right. This next step is super important. I'm going to go as slow as I can. Stop me if something does not make sense. You're going to stop me, right? Okay. So stop me if something does not make sense. I'm going to go slow. It says, let's observe the behavior of f prime when f is concave up. So here we go. I'm going to draw an x-axis. I don't care about the where I am on the y scale, so I'm not going to draw a y scale. Here's my x-axis. I'm going to call this f. And I'm going to draw something that's always concave up, like a parabola. And you know what? We'll make it end. I'm going to call this point A. I'm going to call a point in the middle that is still decreasing, point B. I'm going to count this point right there, point C. And then point D and point E. A, B, C, D, E. Are we okay? All right. I'm going to do another grid, and they're going to be correlated to each other. But this one I'm going to call F prime. And I'm going to be drawing, I don't care about the magnitude, I just care about, like, is it positive or negative? And is it like, well, I do care about the magnitude, but you'll see what I'm talking about. So I'm going to space them A, I'm going to put B, I'm going to put C, D, E. It's correlated to those A, B, C, D, E. We still okay? All right. At A, your F prime is a negative number because I have a negative slope. Do you guys agree? So I'm going to go to A here, and I'm going to put a point. I'm going to put a point like, bam, down here below the x-axis because it's negative. I'm going to go to B, and I can see it's still negative, but not as negative. So it's not as steep. Do you guys see that? So I'm going to put a point like right there. on B. At C, I better be touching the what? Yeah, instead of the origin, just call it the x-axis. Do you guys see that? At D, I better be positive. Do we see that, guys? And then at E, it better be a more magnitude, a bigger positive number. And we have this. This is f prime, my derivative curve. Are we okay with that? Okay. Are we shocked that when we drew a parabola, we got a linear line for a derivative? You shouldn't. I want to just make a connection. I'll just say it. I'm not saying this is it. I'm not saying this is, but isn't a parabola something like x squared? And look what the derivative of x squared is. So I'm supposed to get a linear line when I take a derivative of a parabola. Does that make sense? Okay. All right, but that's not the point. That's not the point. This is the point. Okay. Now I'm going to do the same thing, but I'm going to draw it concave down always. So here's my x-axis and concave down. And let me pick some points again. A, B, C. I didn't do a good job on this one. That's fine. D, E. This is F again, just like last time. Bless you squared. And then here is F prime. Oh, this one's going to be positive to negative. Yeah, that's fine. And A, B, C, D, E. Okay, here we go. At A, it looks like I have a pretty steep positive slope. Do you guys see that? So I'm going to pick a point magnitude-wise, like up here. Something like that. At B, it looks like I still have a positive slope, but notice it's not as steep. It's flatter. So that means my slope is a smaller number. Something like maybe that. Are we still okay? At C, it looks like I have a horizontal tangent. So it looks like maybe something like that. At D, I notice that I have a negative tangent. So maybe something like this. And then at E, I notice that it's pretty steep, but in the negative direction. So maybe, and it's okay if it doesn't look linear. Try to make it look linear, but it's okay if it's not, as long as it looks like it's going downhill. Okay. I think we did a good job. Yeah, we did a good job. Let's see if we can make a conjecture about f prime prime, the second derivative. No. Okay. So notice when it's concave up. So I'm going to write here. So let's make a conjecture. If f is concave up, so write that down. If f is concave up, comma. All right, so let's notice something here. Do you agree? So I need y'all's attention real quick, guys, because it is pretty important. Do you agree that f is concave up over the entire interval here? Tell me something about f prime. F prime is what? Perfect. If f prime is increasing, what does that tell me about f prime prime? Perfect. That's what I wanted to hear. F prime prime is positive. And don't worry, we're going to, in case you don't get it, we're going to break it down even more. Let's put a bullet on that. Second bullet. Now let's observe the concave down. If f is concave down, Tell me something about f prime prime. Notice f prime is what? So if f prime is decreasing, tell me something about f prime prime. Perfect. F prime prime is negative. Those are going to be universal truths always. Cool? All right, so let's put some rules down so let's make sure that we're all on the same track. You only have 4 types of graphs. These are the only 4 graphs you can have. You can either have, let's talk about f increasing. F is increasing. F is increasing. You can either have a graph being concave up or concave down. That's 2 of them. And I'm going to write f is decreasing. You can either have f is concave up or f is concave down. Do you see how both are decreasing graphs? Those are the only 4 types of graphs you can have. If you're increasing, you can either be increasing concave up, increasing concave down. If you're decreasing, you can be decreasing concave up, decreasing concave down. Are we all in the clear? All right. All right. I don't know if I put enough room in there to write. Maybe we should. Let me see if I can highlight all this. Can I highlight all this? How do I choose all of it?
So it's like for f decreasing, concave up has
Yeah, let me see.
and versus like for concave down, it would have a decreasing.
Yeah, we're going to talk about that right now because it can get real confusing real quick. All right. I think, yeah, look, concave down, concave up. They're both decreasing. I just made it smaller. All right. This can get confusing so fast. So let's chat real quick. Ready? I'm going to put a bullet and I'm going to tell you what it means. If, what do I write first? Okay. F prime, okay, say it again. I put f is decreasing. And these are decreasing graphs, right?
You change the one so that it looks like how the other one is really
Yeah.
bad.
Yeah, because at first you had.
It's the same thing. It's just
Yeah. All right. Here we go. I'm gonna make a conclusion statement about what I wrote on the top. If f prime prime is positive, that's what that means. Semicolon. It means 2 things. What are the 2 things that it means? It means this. It means f prime is increasing. And it means f is concave up. Does that make sense? Here's my second bullet. If f prime prime is negative, it means 2 things. It means f prime is decreasing, and it means that f is concave down. Does that make sense? Okay. I think we're going to start slow, and when we get more advanced, we will talk more. So look at example 2. We started off with something we know for a fact is concave up. Do you agree that x squared is always concave up? So it doesn't matter that I gave you an interval. I better be getting a positive number, just a positive number all the time for every x value. Does that make sense? All right. It says use a concavity test to determine the concavity of the given function. All right, I got to take the derivative twice. Y prime is 2x. Y prime prime is 2. So you're going to write y equals x squared is concave up for all x values since y prime prime is positive. No, we don't care about that. It just wants to know the concavity. Are we okay with that, guys? All right, look at this one. This is a sinusoid. So it definitely... Okay, what's up?
Y prime prime or Y prime?
There's 2 primes in there. Y prime prime. Because the second derivative is positive?
But is there 2?
Yeah, there's 2 primes.
There is? Oh my god.
There's 2 primes. Yeah. All right, here we go. Y prime. The derivative of 3 plus sine x is cosine x. Y prime prime. What's the derivative of cosine x? Negative sine x. Now, you can do a railroad track if you want, but on this one, don't go forever. I'm going to call it f prime. Oh, I guess I'm going to call it y prime prime because I wrote y prime prime. Y prime prime. And then I would go like this, where I start at 0 and I end at 2 pi. And I have one critical point, pi. Shav, how do you know? How do you know you have the critical point at pi? Because I took pre-cal and geometry. And I know that sine x is 0 at pi and 2 pi. Right? Okay. So then I'm going to put, all I care about is the sign. Between 0 and pi, sine is positive, but I have a negative in front of this. So this will be negative. Do you guys see how I got that? Yeah. All right. Between pi and 2 pi, sine would be negative because you're in quadrant 3 and 4 in the unit circle. But I have a negative in front of this, so negative times the negative is a positive. Do I have a point of inflection? Yes. Yes, at pi. So for this one, I would say y equals 3 plus sine x is concave up on interval 0 comma to pi. Oh, nope. Well, I already wrote concave up, so I'm right. I know out of order, but pi to 2 pi. Since y prime prime is positive on this interval. And then I'm going to put period, and I'm going to do the next statement. Y equals 3 plus sine x is concave down on interval 0 comma to pi, since y prime prime is negative on this interval. Sorry, I hope it doesn't bother you that my intervals are reversed. If they are, just change the statements, no big deal. How do we feel? Yeah, we're gonna ask you more and more questions, but we're rookies right now. We're just getting started. Oh no, well if they do, that's fine. All right, here we go. Find all points of inflection for the graph e equals negative x squared. They're being nice. This is the graph y equals e to the negative x squared, and I can see here. Do you guys recognize that number, 0.707? Does it look familiar to you guys? No? You've never seen 0.707 in your life.
Maybe.
What about 0.866? You've never seen 0.866 in your life.
Probably, but
Yes, I feel like it's something you told us to remember.
No,
Is it 6 over 8?
no.
No.
I'll give someone 100 right now if you can tell me where you've seen that 0.707.
Wait.
You got 5 seconds.
Code. Right now. Maybe
All right, don't worry about it. Don't worry about it. You're gonna get it right now, anyways. All right, let's find that point by hand. You'll see it right now, and then you'll be like, oh, okay. All right, here we go. We're gonna take a derivative. How many times are we gonna take the derivative? Twice. Y prime equals chain rule. The derivative of e to the negative x squared is itself. E to the negative x squared times what, Tovar? Times negative chain rule. Yeah, negative 2x. Good job. That's it. Cool or not cool? Make it pretty. Negative 2x e to the negative x squared. Now I'm going to take the derivative again. So when I take my second derivative, what rule do I got to use? Product. Now I know some of you like to do it the way Delta does it. That's fine. I like to do it this way. First, negative 2x times the derivative of the second e to the negative x squared times the negative 2x again, plus second, e to the negative x squared times the root of the first, negative 2. Are we okay? I don't see any initial mistakes. Excuse me. Let me go ahead and see if I can make this pretty. Negative times a negative is a, so I see 4x squared e to the negative x squared minus 2e to the negative x squared. I'm going to equal this to 0 because I know that I have a point of inflection whenever my second derivative changes signs from positive to negative or negative to positive, right? So I'm equaling to 0. So I'm going to factor out, it looks like I can factor out 2e to the negative x squared. If I do that, it looks like I'm going to have 2x squared minus 1 equals 0. I do not have to worry about this, that 2e to the negative x squared is always going to be positive. Always positive. But this guy here is definitely going to give me 0 for sure. So I'm just going to go 2x squared minus 1 equals 0. 2x squared equals 1. X squared equals half. Square root, x equals plus minus 1 over square root of 2. Right? Plus minus square root of 2 over 2. 0.707 is square root of 2 over 2. Which you've seen many times with the unit circle, coordinate square root of 2. It's okay, no big deal. Let's make sure that it definitely does change though. So here we go. I would have done this. Railroad track. I would have called this y prime prime. Those are my only critical points. Negative square root of 2 over 2. Positive square root of 2 over 2. And I gotta have I gotta change. It needs to change signs. If it doesn't change signs, it's not a point of inflection. I'm gonna choose a number to the left of negative square root of 2 over 2. So like negative 1. If I put negative 1 squared, remember, this guy is always positive, so you don't even worry about that guy. Negative 1 squared is 1. 1 times 2 is 2. 2 minus 1 is positive. Do you guys see what we did there? If I put a number between there, it's like 0. In case I know I see some of your faces. You're wondering, how do you even know what that number is without a calculator? If you're worried, look, there's no other numbers. Like, just choose like negative 10, negative 100, and like you'll get it right no matter what. Does that make sense? Okay, and then a number between there. Look, notice there's a change in sign. Child, I don't know what that value is. You don't have to know. One's negative, one's positive. What's the easiest number? 0. So you plug in a 0. 0 squared is 0 times 2 is 0 minus 1 is a negative. Put a number bigger than square root of 2 over 2. Chop, I don't know what that number is. I need a calculator. No, you don't. Just choose something ridiculously huge. 10, 100, 1,000. It doesn't matter. Well, I mean, you can see it, but just in case, because I can see some of y'all's faces like, I don't know how to do that. So just choose something ridiculous. 1, 10, 100, whatever. Plus.
That was a bad time.
No, you're good. You're good. Yes or no? So look, does my second derivative change signs? This is not max or min. I just want to know if it changes signs. Yes, because it changes signs, this is a point of inflection. Does my does square root of 2 over 2 change signs do I change signs at square root of 2 over 2? Yes, so it's a point of inflection. So do not say max or min. Child, what does this mean? This means I am concave up between negative infinity and negative square root of 2 over 2. And look, it's correct. Right there, let me change the color to like a red. That looks to me, that looks like concave up forever. You guys see that? It's going to just be ever so lightly, but it's curved, concave up. And then look, this in blue, that in blue for sure is concave down, 100%. Do you guys see that? And look, that's concave down. And then look, concave up, this in green again. Look, that's definitely concave up. Explain which one. Yeah, this does not tell you max or min, because this is a second derivative. That's why I always label my railroad tracks. The second derivative tells you concavity. That's what we did when we were doing this right here. See? That's how we derived it. We said, okay, what's f? This is always concave up. What happened with f prime? It's always increasing. F prime prime is positive. Do you see what we did there? So,
The second derivative always tells
second derivative always tells you concavity.
Okay, but like it only tells you concavity. It doesn't tell you.
That's it. Well, that tells you more than it tells you about f prime. But what does the second derivative tell you in terms of f? Concavity. How do we feel? Okay. This is the last question before I might break this assignment up into 2 days because I'm scared that if we continue past this, we maybe. So we're going to stop after this question here. Example 4. If you understand this one, you are good to go because this is the type of question we're getting close to the real type of free response questions. What's up, Alvarez? No, between negative infinity and negative square root of 2 over 2. The one in red here, see? Concave, or now it's green. Yeah, negative infinity to negative square root of 2 over 2. That looks concave up to me. Right? Concave down between negative square root of 2 over 2 and square root of 2 over 2. And then concave up again. No. But we're good now, right? Okay. Now, there's going to be really good stuff out of this for you, especially because you're going to be a boss engineer. All right. All right, guys. This is the most important question today. And then we'll stop and do our little handout. All right. The graph of the derivative of a function f on the interval negative 4 to 4 is shown to the right. What graph do I have here? The derivative graph. Label it before we do anything. F prime. What graph are you looking at? The derivative graph. Are we in the clear? All right. Answer the following questions about f. So they want to know about f. Justifying each answer with information obtained from the graph of f prime. Are you guys ready? On what intervals is f increasing? So far, I haven't heard a right answer yet. Negative 4, no. I mean, you're increasing negative 4, but not.
Negative 4 to negative 2, then negative 2.
A little okay. That's a little. There's a you're. Oh, that's an okay answer. There's a better answer. Nope. All right. Let's stop. Because all right, here we go. Let's slow down. Some of you are tired, and some of you are trying your hardest to concentrate. Get up if you feel you need to get up to get more oxygen to the brain. All right, here we go. I'm gonna go slow. All right, guys, focus. F is increasing when f prime is positive. Yes or no? Yeah. What graph do I have here?
F prime.
I have f prime. So I'm looking where f prime is positive. F prime is positive. I'm going to outline it. If you have colored pencils, it is a good place to have colored pencils. F prime is positive wherever you see blue. And I guess for a moment on negative 2 it's 0, but so I'm going to put a circle there. The circle didn't come out very good. All right, it you know what? It's all good because negative 4 to 1. Yeah, someone said it, but I think you said it first. All right. Yeah. All right. All right. So here's what you said, and let me clarify your answer. I said, where is the function f increasing? And one of you said negative 4 to negative 2, and then you said negative 2 to 1. That's where f prime is positive. Remember, f prime is positive, negative 4 to negative 2, and at negative 2 it's 0. It's not, and then negative 2 to 1 is positive. But where am I increasing? From negative 4 all the way to 1. So here we go. How do we write this? F is increasing on the interval, parenthesis, negative 4. Actually, you can put the bracket on that. Bracket, negative 4, comma, to 1, close bracket, since f prime is positive on the interval bracket, -4, comma, -2, parenthesis, union, -2, comma, 1, bracket. That's like what we did yesterday.
Okay, wait. So how do we know when to use? I know we use the brackets and the parentheses based on like include not included, but how do we know when to use brackets and parentheses for like increasing?
Okay, the right answer is on the AP exam, not that we're teaching to the test because we are not, 100% not. But on the AP exam, they're not going to matter, parentheses or brackets, because different books use different, different. But it's supposed to be a bracket. You increase and decrease. Yeah, when increase and decrease, you increase and decrease on an interval.
When you're positive, that doesn't include zero, but when you're increasing, it includes zero.
Well, because of the definition of what increasing means. Remember that the definition of increasing, you read a graph left to right, and as long as the right pixel is larger than the pixel to the left, you're increasing. So even though at -2 you are stopped for a moment, that pixel on the F curve is smaller than the pixel to the right of -2. That makes sense? Okay. How do we feel, guys? Alvarez, you doing okay? If you want, you could have also put increasing where F prime is positive 0, and you could have put increasing on this. You're not wrong, but this is the better answer. Yeah. Valencia, you doing okay? Tovar? Severa? Gonzalez? Oh, Gonzalez is not here. Sorry, Gonzalez. LOL. What's up, Abdul Kareem?
So for the one, what if like I know it doesn't matter, but just like is this supposed to be a parenthesis because there's like exact zero?
Oh, yeah. For the F prime, yeah. Yep, you got an error on mine. All right, Abdul Kareem caught an error on mine. Right at 1, it's at 0. So just on this one, for the F prime, where I say it's greater than 0, that should have a parenthesis on that end. But the top line is correct. You increase and decrease on an interval. In case you're wondering, Alvarez, it's a technicality. She's saying this. When I say F prime is greater than 0, notice I didn't put an equal sign in the bottom. So I specifically am just saying, where is F prime positive? Well, I'm not positive right at -2. At -2, it's 0. And I'm not positive right at 1, because at 1, it's 0. You see what I mean? Oh, okay. I don't know if you were asking or you had that look, like maybe. Okay. You're increasing. Yeah, you're increasing on top. -4 all the way to 1, you're increasing. Yeah. Yeah. All right, here we go, guys. On what interval is the graph of F concave up? Ooh, I like that one. Well, I already have F prime. Okay, so how do I know when the derivative of F prime is positive? If F prime is what? If F prime is increasing. Well, that's what we just did right here, guys. If F prime is increasing, look, this right here. If F prime is increasing, F prime prime is positive, right? So they want to know, where am I concave up or concave down? Concave up. So this is F prime. Let's look where it's increasing. It looks like I am increasing from -2 all the way to 0, and then one more time from 3 to 4. Now, for concavity, use parentheses. Don't ever use brackets on this one. You're going to write F is concave up on the interval. Let's see, parentheses, -2, comma, all the way to what? 0, and from what to what? 3 to 4. Always use parentheses, because the definition of concave up is where the second derivative is positive. Not where the second derivative is 0, where the second derivative is positive. Does that make sense? Okay, so you're not right at -2 and right at 0, like you're like those endpoints. F prime prime is not positive. F is concave up on the interval -2 and 0 and 3, 4. Since F prime prime, no, you know what? I'm not saying F prime. Since F prime is increasing on these specific intervals. And I'm going to put a parenthesis, and I'm going to say f prime prime is positive. Close parenthesis. Because there is good notes here. In case you're wondering, okay, I'm going to slow down because I can see a lot of you writing. You could have said since f prime prime is positive on those specific intervals. Chav, which one do I say? There's so many choices. What graph are we given? That's the graph you want to reference. When you become a doctor, when you become an engineer, you're talking to a normal person, right? You're talking to a patient. When you become a doctor and you give the patient their chart of the drugs that they're taking and their metabolism and all that, you're not going to be talking about you're not going to be using medical terminology. You're going to be using that graph. Like, oh, sir, your cholesterol should be at this line and look how high above it is. That's not good. You're always referencing what you have. So you're going to be referencing this f prime. Cool? Okay. All right. Don't worry. We're almost done, guys. We just have 3 more. Letter D, E is my favorite. At which x coordinate does f have a local extrema? Yes, yes. Do you feel the power? No, this is awesome. This is awesome stuff. At which x coordinate does f have a local extrema? So I want max and mins. So let's forget. Yeah, let's make it simple for now. Don't worry about the endpoints because there is something going on at the endpoints because of that. But where do I have a max or min? When what happens? Yeah, you said it right now, Abdul. Where what changes signs? Don't say it. Where f prime changes signs. Are we in the clear? So I see that f prime is positive all the way until I hit what? 1. So at 1, I have a what type of extrema? Max or min? Max. Why?
Because it's going up and it's going down.
Tell me something about f prime.
F prime is increasing.
No, don't say increasing. It's not increasing right there.
F prime is positive.
To negative. That's what you're going to say. You're going to say, okay, I'm going to put in parentheses excluding endpoints because there is something going on at the endpoints. Excluding endpoints, parentheses, comma, f has a local max at x equals 1 since f prime is changing from positive to negative at x equals 1. Notice how specific we are, guys. Sorry, Abdul Kareem, I'm going to throw you under the bus real quick. What Abdul Kareem did a little while ago, she said it is changing from positive to negative. I can't tell you how many times I have graded AP exams through College Board, and when the student says in the free response, it is changing from positive to negative, we cannot award them the point. Like, what is changing positive to negative? Are you talking about F? Are you talking about F prime? Are you talking about F prime prime? Do you know what I'm trying to say? Yeah. You have to be specific to get the point. When you become a doctor, when you become an engineer, when you become an accountant, be specific. F has a local max at x equals 1 since F prime is changing from positive to negative. When you become a lawyer, you're going to be super specific with words. All right. There is something going on at the endpoints. We will talk about that later on because I feel like right now it's too soon that we're throwing you guys a whole bunch of stuff. Letter E. What are the coordinates of all inflection points for the graph of F? Remember that inflection points come where the second derivative changes what? Where the second derivative changes signs. Yes or no? So I am looking where my second derivative changes from positive to negative or negative to positive. I don't have my second derivative. Or where my F prime changes from what to what? No, not. Increasing to decreasing or vice versa. Does that make sense, guys? Okay, just put it in your head real quick. F prime increasing means F prime prime is positive. So I'll put it over here. I'll put it up here. F prime increasing means F prime prime is positive. And I'm going to write the next statement in blue. f prime decreasing means f prime prime is negative. Does that make sense? All right, let's look at this graph. Where does this f prime graph change from increasing to decreasing or vice versa? -2, that's one of them. 0, that's another. And 3. Do you guys see how we found that? So here we go. This is what we're going to write. We're going to write f has inflection points at x equals -2, comma, 0, comma, and 3, since f prime is changing from, and you always want to say the first one first, decreasing to increasing, from decreasing to increasing, and vice versa at those specific x values. Perfect. Sorry, I did. I'm gonna edit the video, so I had to mark the time. All right, are we still okay? I thought of something, but now I'm gonna forget. So don't ask questions right now because I know. All right, how do we feel? Okay. Sketch a possible graph of f on the interval -4 to 4. All right, here we go. Sketch all possible graphs of f on the interval -4 to 4. Guys, this could be hard or it could be easy. Make it easy for yourself. There's only 4 types of graphs. How many types of graphs are there? 4. So, Chav, how do you know what are the 4 graphs? Okay, f is either increasing or decreasing. Okay, Chav, that's only 2 of them. Relax. If I'm increasing, I can either increase concave up or increase concave down. That's it. Yes or no? If I'm decreasing, I either decrease concave up or decrease concave down. That's it. Yes or no? All right, so here we go. Let's do a sketch. So, and I'm not saying it's going to be perfect. So let's look at our f prime. Notice that f prime between -4 and -2 is decreasing. So because f prime is decreasing, that means that f better be concave down. Now f prime is positive, so that means f is what concave down? F increasing concave down. At -2, I have a horizontal tangent. So here it is. Ready? So we're going to draw a concave down, increasing graph. Concave down, increasing graph. And I write at -2, so here's -2, horizontal tangent. That's concave down, right? Okay, perfect. Now let's go. Let's look at the interval again. Between -2 and 0, f prime is increasing, so that means what? Concave up. What about f prime? Is it positive or negative? Positive. So I am increasing concave up. So go between -2 and 0, increasing concave up. So I'm going to do it I'm going to color code it. Increasing concave up. And at 0, yeah, no horizontal tangent. Just keep going. Increasing concave up. Okay, that's x equals 0 right here. All right, let's see. Between 0 and 1, I'm still positive, so I'm still increasing, but it's f prime is decreasing, which means f has to be concave down. So let's do concave down. And right at 1, I have a horizontal tangent. Perfect. Bam, x equals 1. So we're doing pretty good. You can see my 3 little sketches right there. See? Boom. And then let's see, between 1 and 3, f prime is negative, so that means f is decreasing, and f prime is decreasing, which means f is concave down. So decreasing, concave down. So decreasing, concave down. Bam. Looks good. And then right at 3, now I'm increasing. I'm still concave down. I'm sorry. F prime is increasing, so I'm concave up, but I'm still decreasing. So concave up, still decreasing. So let's see. And then right at 4, horizontal tangent. There it is. It doesn't have to be perfect. Kind of looks like an elephant, like the top of an elephant, right? That looks like an elephant to me. I see like legs here, the trunk there. Oh, look, elephant. Ah. Okay. Do you see how we did it, guys? How are we feeling? All right. You think we can take some more or no? No? Okay. Yeah. All right. So let me pass out today's handout. I'm not sure what page. Let's see. 1, 2, 3, 4, 5th page. All right. So look what the theorem 5, and you know what? You can just scratch out theorem 5. We're not even labeling. What's this theorem? What's that theorem? That just comes from a textbook. Let's see if we understand what it says. If f prime is 0 and the second derivative is negative, then f has a local maximum at x equals c. Do you guys understand like what it says there? No? Okay, we'll talk about it. No big deal. If f prime equals 0 and f prime prime is positive, then f has a local minimum at x equals c. All right. Let me tell you first and foremost, if you have an expression for the first derivative, the second derivative test you would never do to test for max or mins. Because if you have an expression, all you got to do is check where the first derivative changes signs. Yes or no? Yeah, the first derivative changes from positive to negative. F has a max because think about it, positive to negative. If the first derivative changes from negative to positive, that means f has a min. Now this is saying, when do you use this? And there was a free response question a few years ago that they didn't give you an expression. They just gave you the second derivative, and they wanted you to prove that it was a max or min. I can't remember, but we're going to do it in this classroom eventually. So here's how it looks. Do you remember what second derivative being negative means in terms of f? It's concavity. Concave down. So look what the first expression says. It says that I have a derivative that is 0, and I'm concave down all the time. So how does that look? It looks like this. And here's that critical point, C. And look, yeah, sure enough, there's my derivative that's 0. And look, this is, by the way, there's that. And it's concave down. So what is this? C has to be a max. Yeah, C stands for critical point. My critical point at C. Does that make sense? If I have a critical point, let's see how the second one looks visually. So if you have a critical point, and that critical point has a derivative of 0, and my second derivative is always positive, that means I'm concave up. So concave up, here's my critical point. See how it's flat there? Notice that's a min. That's what this definition is saying, guys. Oh, you guys are going to love tomorrow, by the way. No, I thought about you guys. I really did. We're going to do a hands-on activity. Yeah. Oh, maybe. I don't know. That's a good one. Maybe we should bring tacos. You guys want tacos? Okay. We'll do taco breakfast in my room tomorrow. Not like in the morning, like this class and this side. And we will do a hands-on activity. So there.
Are you gonna tell us what it is, or is it a surprise?
You're gonna do a matching activity. It's gonna be fun. It's gonna be fun. All right, here we go, guys.
Wait, stop. What's a concave?
What's the concave? This is concave down. This is concave up. Oh, here. You'll know everything from just this expression right here. Do you see this? So concave down, concave up, and then right smack in the middle is an inflection point. So that's where you change concavity. You know what I mean? Don't worry, I'm gonna upload the video. This on the first page. Oh, she wasn't here in the first half. All right, no problem, no problem. All right, here we go. You guys ready? All right, let's focus, miss. Use the second derivative test to find the local extreme values of this function. So, second derivative test. First, let's take the first derivative. F prime of x equals the derivative of x cubed is 3x squared. The derivative of 12x minus 12. And I'm going to equal this to 0 to find my critical numbers really quick. So equal that to 0. I'm going to factor out a 3. So I have x squared minus 4. So where will give me my critical values? Plus minus 2. Are we okay? Okay, all I did right now is found when my derivative was 0. For what values of x is the derivative 0? For negative 2 and positive 2. Cool or not cool? All right, now let's do the second derivative. F prime prime of x equals, what's the derivative of 3x squared? All right, so let's do f prime prime of negative 2. That's a negative 12. And let's do f prime prime of positive 2. That's a positive 12. How do you feel? All right, since, so I'm going to start writing here. Since f prime of negative 2 equals 0 and f prime prime of negative 2 is negative, comma, x equals negative 2 must be, so let's stop real quick. Visualize in your head, I have a horizontal tangent and I am concave down. If you have a horizontal tangent and concave down, it must be a max. You're concave down, max.
Oh, yeah.
Does you guys see that visually in your head?
Yes.
Okay. X equals negative 2 must be a max, period. I'm going to write my next statement. I'm going to change my colors, and I'm going to write since f prime of 2 equals 0 and f prime prime of 2 is positive, comma, x equals 2 must be, and let's visualize it, concave up, and I have a horizontal tangent. So that must be a minimum. Does that make sense? All of them are local. All of them are local. They're not necessarily absolute, but all of them are local. Does that make sense so far? Okay, where did I lose you, miss? Okay. So all we're saying is, do you know this visual here? Okay. If I have a critical point, and at that critical point I have a horizontal tangent, do you see how that's a horizontal tangent? So that means my derivative is 0, right? The first derivative. And if my second derivative is negative, remember what that means. If the second derivative is negative, that means f is concave down. So do you see on this image here how this point must be a max? It's the highest point in the whole curve. So what's the rule? If you're concave down and you have a horizontal tangent, it's a max. If you're concave up and you have a horizontal tangent at that critical point, it's a min. And you got to be able to visualize that in your head. Does that make sense? Okay. Yeah, no, it's hard, miss, especially if you're thinking about a lot of stuff at one time. But let's try to focus on just one thing right now, and I think you'll get it the more we do it. Okay. Here we go, guys. Let's go to the next question. So now we just got some questions. Oh, actually, we're almost done. We just got this, and that's it. All right, true or false? If the second derivative is 0, then I have a point of inflection at that point.
No.
So is it false? It's 100% false. Why?
If the first derivative is 0, then first of all,
No.
because that's the clear point. False because reflection indicates nor concave down to that middle point versus.
You're close, but not close, but not close.
Isn't it? What can we apply
that second derivative changes what? The sign. The second derivative must change signs for it to be a point of inflection, guys. Because if it goes from second derivative positive, then 0, then positive, that's not a point of inflection because you're still concave up. Does that make sense?
Yeah, because it's not negative.
Yeah. So I'm going to write false, and I'm going to put semicolon. I'm going to write second derivative, or f prime prime. F prime prime must, and underline the word must, change signs at x equals c for x equals c to be considered a point of inflection. False. F prime prime, the second derivative, must change signs at x equals c for x equals c to be considered a point of inflection. Actually, you might even be able to delete the word considered for it to be a point of inflection, because we don't consider it, it's a point of inflection. Does that make sense? Okay. All right.
Quick question.
Yes.
If this is the point of inflection, why, if it's changing signs, like it is, like you have to pass, so if you're changing signs, do you just skip the 0?
It's possible that second derivative could be undefined. Like I'm trying to think of something like, see, like that. Maybe the second derivative does not exist because it's like a jerk. But I'm still concave up immediately after it. Concave up, concave up.
No, it's not for sure point of inflection because even whenever it goes, whenever it stops at 0, it stops going down. So it's not.
It would be ideal that we go through 0. If it's a nice smooth change,
Which is why
something like that would definitely have a second derivative equals 0 right smack there. See, concave down, concave up.
Yeah.
So it would be ideal, but if there's like a sudden jerk at that at a location, then it's not going to have a second derivative. As long as the function's continuous.
And yeah, so why would that be considered?
This is not a point. This is a point of inflection.
Yes.
Yeah, this is a point of inflection. But it's not always gonna. What if I have something like this?
No.
The second derivative is 0 here, but it's not a point of inflection.
For number 1, is it like?
Oh, so it can be, but it's not always, which is why you can't make
Yeah.
it.
Look at this function. F of x equals x to the 4th. F of x equals x to the 4th looks like this, but very skinny. So if I take a derivative for x cubed, f prime prime x equals 12x squared. Well, where is 12x squared equal to 0? At x equals 0. But is x equals 0 an inflection point for x to the 4th? No, because it's always concave up.
Okay, so basically, what I'm trying to say is that, like, number 1, it could be true in some scenario, but it's not a statement you can make because it's not always true.
Correct. And
Okay.
the second derivative must change signs.
I was confused because I was picturing that, that graph.
Yeah, the second derivative must change signs. All right, let's see what the next question says, guys. The next question says, if f prime of, okay, so here you go, Tovar. This is your question here. If the first derivative is 0 and the second derivative is negative, does f have a local max? So let's visualize this. So I have a horizontal tangent. And what does this mean? Second derivative is negative? Concave down. So here's my concave down, and here's my critical point. That's the only place in this curve where they have a horizontal tangent. Is that a max? Yes, this is true. Semicolon, this is second derivative test. Second derivative test for local extrema. Second der test for local extrema. Everything's local. It's not always absolute, but
And that's your justification?
yeah,
Okay.
that is my second derivative test.
Well, we've been so wordy.
Oh, we're still going to be wordy. All right, here we go. The x-coordinate of the points of inflection of the graph, blah, 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 and you don't have a calculator, are, well, let's find out. You guys ready? I take a derivative. Y prime equals 5x to the 4th minus 20x to the 3rd plus 3. Am I done with that derivative? I need a second derivative. Y prime prime equals 20x to the third minus 60x squared. And I set this second derivative equal to 0. Yeah, if you have an expression, you're always going to equal it to 0. So maybe that's why you're like, whoa, if it equals 0, that must be a point of inflection. You got to see if it changes signs. I'm going to factor out. What am I going to factor out? 20x squared. And I'm going to be left with x minus 3. So I have two values. And I guess one time I did a mistake, and I was with a professor, and I'm like, yeah, we are going to find our critical values. And the professor immediately was like, there's a second derivative equals 0. Those aren't critical values. By definition, the critical values with a derivative equals 0. I'm like, all right, Dr. George. So I'm not going to call them critical values anymore, second derivative. That's only where the first derivative equals 0. But I always think we're equaling it to 0 because something's happening. So that's what I think the word critical means. But we'll leave it to each their own. All right. Yeah, I'm going to do a railroad track. This railroad track is not for the first derivative. It is for the second. I'm going to put 1 at 0. I'm going to put 1 at 3. I'm going to put values. Do I even care about the 20x squared? No, that will always be positive. Unless it's x equals 0, of course. But it's always going to be positive no matter what. So all you got to do is focus your energy on the x minus 3. If I choose a value to the left of 0, like -1, -1 minus 3 is negative. If I choose a value like 1 or 2, 1 minus 3 is negative. If I choose a value like 5, positive. All right. Is x equals 0 a point of inflection? No, because I go from concave down, and then for a moment, it's like, oh, and then I still continue concave down. What about at x equals 3? Yes, because concave down, then at 3, I change to concave up. So I change signs. So I only have it at 3. Yay or nay? Okay, so now real quick, we got to talk a little bit about basic algebra. And it's fine, guys. It's not. Don't worry. We're not making fun of anyone. Okay, when you see this statement, what does that mean? It's positive. F is positive. This means positive. Means positive. So if I have a graph and I call this F, you guys see this? Yeah. And I go, and let me just, you know what? I'm going to end it. I'm going to end it right there. So I'm going to start it at A, this is B, this is C, this is D. Where is F positive? Between what and what? B and C. F is positive on BC. The interval is BC, not a coordinate point. Notice I didn't put brackets. Yes. Yes. X, you could say my X value greater than B, smaller than C. They're the same. Yes. Does that make sense, guys? Okay, now what does this mean? F prime, let me put another point here. A, B, C, darn it.
Teachers, please pardon this interruption. If any teacher on campus has not received a phone installed into their classroom, please beg the front office at this time. Again, if you do not have a phone installed in your classroom, please call the front office. Thank you.
Like manual phone phones, like office phones.
All right. If I say where, this is still F. This is still F, guys. And I'm going to erase this F prime 0 here. Where is F prime greater than 0? Remember, F prime greater than 0 means where F is increasing. So on the interval, where is this increasing from A to C? So, yeah. Yeah, you can put brackets. A comma C. But if I tell you where F prime is 0, then you will put parentheses. Increasing on A to C. Does that make sense, guys? Okay. I think we covered what we needed to cover. Do we have any other questions on any of that? Okay, one last thing because we got some deltas and we didn't necessarily talk about it, but we should know about it. If I have something like, I'm gonna make up a graph. Let me see, what graph should I do? Okay, so here's my graph. And this is F. A, B, C. I want you to align F prime. I have F prime A, F prime B, and F prime C. I want you to align them in order from biggest to smallest. Can we do that?
Yes.
Yes. Which one of these three, just by looking at that graph, this is F, is the biggest? C. F prime of C, sorry. F prime of C is the biggest because this is the one that has the steepest slope. Does that make sense? And then which one of these, there's only one, has a slope of 0. So this is the only one that has a horizontal slope. Does that make sense? And then this at A has a negative slope, yes or no? So this one you would say F prime of C is greater than F prime of B, which is greater than F prime of A. And I think Delta does it the other way around. They put less than symbols. So they probably put this one first and that one and that one. Cool or not cool? Okay, we have two deltas. At least one of them, take care of them today. You know enough to take care of both. But tomorrow, if you want to save, okay, because one of the deltas is matching F with F prime prime. You don't have experience yet on that. We were going to do it. We are going to do, unless, I die or something. But we're going to do, unless I plan on being here tomorrow. I plan, but you never know. Maybe I'm going to tell you something. Okay, I'll tell you right now. I'm going to do something that I've never done in my life. Oh, I would like to do that, but I don't know if I can. I'm going to force myself to exercise. You know how I'm going to do that? I live, and I got this idea from this morning when I woke up and I started driving, because I went to Grajera's house today, so I started driving to Grajera's house at 6 a.m. To pick up some boxes, because she's not going to be here. Anyways, I don't have to give you the story. So I saw a kid walking at 6 a.m. He was walking to Jeff, obviously, and I'm like, man, why is this kid, he's walking at 6 a.m. to Jeff. Yeah, so that's what I'm going to do. He gave me the idea. He didn't tell me. I just saw him, and I'm like, I should do that. So according to Google Maps, if I walk, Google Maps says I live 36 minutes away. So if I force myself, I'm like, I'm going to leave my vehicle here. If I force myself, then that means I have to walk 36 minutes here, and then I have to walk 36 minutes back home when I get out. So that's an hour that's more than an hour of exercise. So then I have no choice, right? Like, oh, I got to go home. I got to walk. Watch me call an Uber like halfway through. Screw this. Let me get an Uber. Yeah, that's fine. I mean, I'll have my pepper spray or something. So I'll be safe.